All right, welcome to another video. Here we go. This one's gonna be real quick. It is just about arguments. Now I know many of you are gonna roll your eyes because you're like, Miss Clark, I have already written so many arguments in my academic career. And I know you have. I'm so aware that you have. We just need to practice and make sure that we do them how College Board is expecting us to do them. We are going to be writing arguments daily for every quiz and for the exam in May. So it's so important that we learn how to do these right. So here's a quick refresher of what this looks like. All right, so as we mentioned, you're going to be asked to write these argument statements on a daily basis in class. Almost every single time, you're going to be given some form of data. Now, in this situation here, it's going to be a graph. However, other times, it could just be a table. So some form of information. Then we'll be asked to answer a question about it. So this question here says, over the course of a year, the water temperature in a stream varies between 10 degrees and 35 degrees. Very important that we start annotating this. Would you expect the fish species A or B to be more abundant in the stream? The question is asking, would you expect fish species A or B? So our answer needs to start with, I would expect, but we'll get to that later. So let's now figure this out and how to use the data with it. We're going to start with the 10 and 35 degrees Celsius. So I notice here that this is dissolved oxygen, which we're going to call DO, and this is our fish population, which is either species A or species B. This is our temperature, and this is our dissolved oxygen over here. So we have a temperature of 10 and 35, 10 and 35, which means that our dissolved oxygen level is going to be at 11 and 7. So we have a DO of 7 through 11. Great. So now we're going to pull that information over here. And we notice that 7 through 11 happens in this area, which means that this is the species that is more abundant. So our answer to the question would be species A. However, we can't just write it that way. We have to add in our evidence and our reasoning. All right, so we're going to start looking at our argument in the form of a CER statement. I know you've done these before so many times, but just as a refresher, we have our claim, then our evidence, then our reasoning. So every single time we answer a question with an argument, we're going to follow this exact method. All right, let's start with our claim. As I mentioned before, the question asked, which fish would you expect? So therefore, I'm going to respond with a very clear claim statement that says, I would expect for fish species A. Very, very clear here. To be more abundant in the stream than fish species B. Most importantly here, we cannot start with the evidence. That doesn't help us. That just makes everything very confusing to piece together as you go. And we cannot start by disproving the counterclaim. Please take a look at these. I've seen many of these as a teacher. So it's very important we start with just our claim statement. Now we're going to go into our evidence. Our evidence is all coming from these graphs. So as we mentioned before, it is connecting the temperature, which is this graph, to the fish species, which appear in this graph. So a great way to do that is to say, since the temperature of the stream varies between these temperatures. The dissolved oxygen level varies between 11 and 7. So fish species A can live in water with DO levels between 4 and 12, which we discovered here. And fish species B can live in DO levels between 10 and 16, and these temperatures create DO between 11 and 7. So it's all about using this data to answer your claim. And then finally, we have the reasoning. I personally feel the reasoning is the most difficult. I know the reasoning can seem over the top, like you are just restating your thoughts again, but it's so important that you connect the dots for the reader. And that's what you're doing here in your reasoning section. This, I think, is the most difficult, so we're going to spend a lot of time working on this. So, since the DO levels of the stream are below what is needed to support species B, we're starting with that. They're at the levels to support species A. It would be expected that species A would be much more abundant in the stream than species B. I know that's so redundant. And you're like, I'm just repeating myself over and over again. I know. But it's so important to put that reasoning in there to kind of close out your argument. This here would be your final argument. And I know it's a lot, so we're going to work on this throughout the year. But I'm confident that you'll be successful. Can't wait to do more and more practice. We'll just see you later.